Hi guys, I'm Deepak Singla from IIT Delhi. In this video, we'll be doing a rule-based DFM analysis for the process water jet cutting. Let's first know what is water jet cutting. Water jet cutting is a process which uses high pressure, high velocity stream of water directed at a work surface for cutting. It is a preferred method when the materials being cut are sensitive to high temperatures generated by other methods such as laser cutting. It is done using a water jet cutter, which is an industrial tool capable of cutting a wide variety of materials using a high pressure jet. The term abrasive jet refers specifically to the use of a mixture of water and abrasive to cut hard materials such as metal organite, while the term pure water jet and water only cutting refers to water jet cutting without the use of added abrasives, often used for softer materials such as wood or rubber. In this video, we'll be doing an analysis for pure water jet cutting. Looking at water jet cutting, we see that this is a source of high pressure water, and this water passes through the valve and through the nozzles, and it is impinged on our workpiece material. The water jet, after cutting through the workpiece, passes through a hole and is drained through the drainage system, which can be again recycled and used for water jet cutting again. Now we'll have a look at the video which shows the process of water jet cutting. Well, that was a very precise part. That shows how precise water jet cutting is. Water jet cutting is usually automated by CNC or industrial robots to manipulate nozzle along the desired trajectory. Water which is used for cutting also acts as a cooling agent in the process. The advantage of water jet cutting is that we can cut very complex part shapes. It is also used to cut narrow slits in flat stocks such as plastic, textiles, composites, and floor tiles. And its disadvantage is that it is not suitable for brittle materials such as tempered glass. The intensity of water jet is not enough as opposed to the solid force to make a clear cut, so the material tends to be spreading out in case of tempered glass. Now, before doing a rule-based DFM analysis on water jet cutting, we'll actually see what a rule-based DFM analysis is. So, design for manufacturing basically describes the process of designing or engineering a product in order to facilitate the manufacturing process to reduce its manufacturing costs. Now, some DFM guidelines are set for DFM practices depending on various types of manufacturing processes, which help to precisely define various tolerances, rules, and common manufacturing checks related to DFM. The rule-based design for manufacturing essentially gives us some standard guidelines which should be ensured at the design stage for the required process, which is water jet cutting in this case. Thinking ahead during the design stage of a fabrication always saves manufacturing cost later. This is also true for the parts cut with a precision water jet. Part production time, assembly time, fixturing, and well preparation time all can be saved if we follow a rule-based design for manufacturing. Now let's look at some rule-based guidelines for water jet cutting. So the first guideline in the section of geometric considerations is taper. So taper is essentially the difference between the top profile of the cut versus the bottom profile. And taper is a side effect of water jet cutting. As the water jet cutting stream rapidly erodes a material, it may do so unevenly, resulting in an uneven edge, similar to the canyon formed by the stream. As you can see in the below diagram, the high taper water jet cutting is not precise While if you see the low taper water jet cutting, it's precise. So we should prefer low taper. So the jet when cuts thin materials at a high speed, this results in greater edge taper than thicker materials. We have to be sure that the design can tolerate the edge taper. For the same reason, thin materials are preferred so that we have a less edge taper. Looking at the second geometric consideration, which is piercing. So piercing basically refers to cutting through the material to make a hole in the component. And with each pierce of the material, we have to wait for the jet to turn off from the previous cut and restart for a new cut and then pierce the material. So if the holes are near the periphery of the part, which can be seen in the diagram below, it is often faster to simply connect them and pierce them. The next rule is the internal and external corners. Water jet cuts large rounded features faster than fine sharp features. So if we close a slot with an arc rather than a square end, the cutting time can be reduced. As you can see in the figures, in the left hand figure, the slot is closed using an arc, while in the right hand figure, it is closed using a square. So the left hand figure is the preferred one. Although the parameter of the rounded hole is longer than the rectangular hole, still it takes less time to cut. The color shows the cutting speed along the tool path, white being the fastest, which shows that the left hand figure will be cut fast. Good. Let's look at the next tool, which is tight radii. Since the water jet stream is a round tool with a diameter between 0.03 inches and 0.04 inches for water jet cutting, creating any inside corner that is perfectly square is impossible. As you can see, at this particular place, the curve width is 0.04 inches. So we cannot create this particular edge which is perfectly square. Going at the next rule, which is tabbing. So tabs are used on the part edge that are used to hold the part in place while it is being cut. To ensure that the finished parts do not snag into the nozzle or fall into the catcher where they are easily lost, tabbing should be done, which ensures smooth cutting of hundreds of small parts from an unintended small plate. As you can see here in the figure, hundreds of parts are cut from a single plate using tabbing. So this is a perfectly correct design. Now let's look at the next rule, which is very important in case of any rule-based design. That is material selection. We can cut almost all materials through water jet cutting. One of the very few materials that cannot be cut using a water jet is tempered glass. And this is because tempered glass is always under stress, and as soon as you begin to cut it, it will shatter into small fragments. Just to see a difference between a tempered glass and non-tempered glass, we see if you break a tempered glass, it will break into thousands of small pieces. While instead, when you break a non-tempered glass, it will break into just some small few pieces that are intact. The preferred materials for designing the components using water jet cuttings are specifically stainless steel, copper, brass, and aluminium. And also, it can be designed using brittle materials such as glass, ceramics, and quartz. Considering the features, that is depth of cut, very limited depth of cut can be achieved through water jet cutting process. Since the cutting process proceeds in a cyclic manner with steady material removal up to a critical depth, followed by formation and removal of steps as the cutting depth increases. Because this critical depth, the material removal is unsteady, resulting in formations of striations or waviness on the wall of the cut surface. So the maximum depth that can be cut using a water jet is just 12 inches in case of water jet cutting. So while designing, it should be ensured that the maximum cut length required is less than 12 inches. And also the component strength should not be affected by formation of striations on the surface. Now looking at tolerances, in general it is not useful to place tolerances on parts to be made by water jet machining, as the machine's path is the same no matter what tolerance is specified. An overall tolerance on how close the part must be to the theoretical line is useful for selecting while machine can be used. On the other hand, features that must be controlled tighter than overall tolerance should be toleranced separately so that it is evident that a second operation must be performed An example for that can be reaming a hole. The speed along the path varies according to the surface finish required. For this reason, finish requirements should also be indicated. We're looking at a summary of all the rules which we discussed in this video. One of them was low taper is preferred for water jet cutting. The holes should be positioned near the periphery. We should prefer closing of slots with an arc rather than a square. Tabbing should be used to cut large number of parts from a single sheet. Regarding material selection, we can use almost all materials except tempered glass. The maximum depth of cut that can be cut using water jet cutting is 12 inches. And lastly, we should use precise dimensions to design the part. We thank all the references that were used to make this video. Thank you.